I ordered this chip, and it is the NE5532 this chip here, because I was very interested in its properties. I studied the datasheet. I got in a certain way the idea that it could work on 10 megahertz, and surely perhaps it can work on that frequency, but anyway. And in the past I have published on YouTube a square wave oscillator made with a TL71, but my idea was that this chip could be better, much better working, and then especially because it had such a high frequency range. And when you study the datasheet, there are of course always limitations, etc, etc. So perhaps my idea that I could get to such a high frequency was not say very clear. Anyway, I made a circuit with it, and it works very properly. So I want to name it in a kind of way, perhaps a poor man's circuit, but it works properly. I hope it is completely visible from this distance. The page is somewhat stretched. I had to glue a certain piece of paper, especially regarding the frequency settings here, etc. This is the chip inside, how it is made, consisting of 2 op-amps. My first idea was that I could use both op-amps in one case, but anyway that did not succeed, of course, because here the positive leads at the inputs were connected, and I did not need that. So I made a first oscillator circuit here, and this is exactly the same chip, and I have by purpose drawn it as it is, say the top view, and this is the output. And the only perhaps important thing is that on the higher frequencies we see not this, of course. This is a very low frequency. It's in the order of 7.7 or 8 Hertz. But what I wanted to show is this. When I go to the highest frequency, here, that's this. This is the highest frequency, and the waveform is no longer a pure square wave, but I think it doesn't matter. In a certain way it doesn't matter. And on lower frequencies it's a pure square wave. Perhaps I thought sine wave, but anyway it's a square wave oscillator. And here is the frequency, the highest frequency, 19.8 kilohertz. I could get it higher in experiments, and especially when I did not use here this complete unit here. That complete unit gives, say, a kind of capacitive effect on the oscillator. Anyway, so when you use it for, say, only one frequency, and that's very well possible, omit this part of the circuit, forget it, use only one capacitor here from pin 2 to ground, and that in that case that capacitor will set the frequency, and that could be in the range of 5 Hertz up to approximately 100 kilohertz or 109 kilohertz. Say this is a typical hobby solution to get to other frequencies and make the whole circuit in such a way that you can align the frequency, set it to a certain frequency with the help of a potentiometer. Thus, when you forget this, you have here a few fixed frequencies, and here, this is a kind of primitive way, by the way, to change the frequency. Let me show it. And now turn that potmeter. Let's see what happens. So it means that in a very, very coarse way, and you can also see the not good properties of this solution. There's noise generated, but anyway, on lower frequencies it can help. And say there's also a certain setting of the switch, the rotary switch, where you can get, without say touching that frequency potentiometer, a completely pure waveform. So anyway, well, let me show it. Now I turn this potentiometer, by the way, here in the circuit. It bridges the frequency dependent capacitor in a certain way, in a primitive way. So in fact you are slowly adding here to the value that's here, to which the rotary switch is set. You are slowly adding here 39 nanofarad. Anyway, in a primitive way, by the way, with that potentiometer. Anyway, I think it's okay. It can work good. Say, don't expect everything from such a simple circuit. It's a simple setup. The chips are very, very cheap. In the Netherlands I have paid, say, 60 cents for this chip, and also 60 cents for this chip, etc., etc. Well, the frequency table is perhaps interesting to show, and it's here. Say, these are the basic frequencies: 4.7 microfarad, 10 Hz, 47 microfarad, 3 Hz, etc., etc. But when you turn that potentiometer that I've talked about, the frequency will change. You get a say bigger frequency band. So in fact, and when you know a little bit about electronics, you will surely see that this is a primitive solution, because when the potentiometer is used, we can go from 342 Hz to 98 kilocycles. So there is, say, no normal potentiometer that can say do that in a, say, more or less proper way. But anyway, the whole circuit is, in my opinion, very good usable. And you can also say, well, I only use this way of aligning here via that 470K potentiometer, by the way. Sorry, no, it's okay. This is a 470K potentiometer here that bridges the frequency dependent capacitor. There's not so much more to tell. I think I stop now. Wish you luck. These chips are the same. The whole oscillator is very simple, easy to make, and I think very useful for hobby circuits. Let me try to switch between the frequencies that are set with via the rotary switch. We are now on 98 kilohertz, and this is the waveform. '97, '96. I have to do one position lower, we are suddenly on 11 kilohertz. You can surely see that the waveform is perfect. And forgotten to tell that you can set, with the help of these two 47K potentiometers here and here, you can set the duty cycle a little bit. Let me show it. I turn only one potentiometer now, by the way. So here you see that you can set the duty cycle. Again, that makes it a good, very good, useful hobby circuit. 15 kilohertz at the moment, beautiful waveform, no problems with that. I'm gonna switch the rotary switch again to a lower frequency. Now we are on 3.5 kilohertz. Beautiful waveform again. Turn again one of the 47K potentiometers to show the change of the duty cycle. So all with all, I think it's a very, very useful circuit. Thanks for watching. Show the schematic again. Pen over somewhat. And this is perhaps interesting to tell here. The decoupling unit, it's here. 470 microfarad, etc, etc. And that I have used this here because perhaps when you want to make it your power supply is not pure enough. That's the reason why this kind of filter is used.